Hi, everyone. Thanks for joining us today. I'm Kevin. I work on the partnerships team here at Wolfram Research. Some of you may also know me from the Eureka program, some stuff that we've been doing with startups. You may have heard about Wolfram Alpha's integration into Microsoft Excel from Stephen's talk yesterday during this tech conference. We're really honored to have the team from both sides that work on the integration with us today to walk us through the integration, specifically looking at our joint goals around improving teaching data literacy and how you might be able to use the integration in the classroom, in your work, and in your everyday life. I want to start by introducing our agenda for today. We'll start by going over our partnership with Microsoft and some high-level ideas on what our joint goals are. We'll follow up by discussing data literacy and the benefits of teaching in the classroom. Next, we'll introduce what are Wolfram data types and talk about what the team here has been working on over the last few years. And finally, we'll go over some ways you might use the integration both in the classroom and in your daily lives. And we'll end with an open panel Q&A. Please, we want this to be semi-interactive. Please leave us any questions throughout the presentation in the chat. There will be a Q&A at the end, as I mentioned earlier in the agenda. I'll be acting as the host and moderator, and our speakers will answer the questions as they can, or any unaddressed questions, we'll make sure to bring it back up during the open panel Q&A at the end. So I want to hear from you first. So please respond in the chat. I know we have a mix of people here, from educators and teachers to engineers and anyone else who's used our technology in the past. There are two questions that I'd like to ask you and hear from you. What are some different ways that you're currently talking about data with your students? And the second question is, for those of us who aren't educators, how does data play a role in your daily life? And please feel free to use the chat bar in Passable to answer these questions. I'll give it a few minutes and I'll call out any of the answers in the chat. Glenn says daily and hourly load estimates. I'm interested in hearing more about what that's about, Glenn. I think perhaps in like the manufacturing realm, I actually worked in manufacturing a while before Wolfram. I was working in manufacturing and kind of thinking about managing a lot of our process management, how things are going from one kind of plant to another to finally its destination. We're really interested in seeing the time it takes, and data is a big part of decision making within the manufacturing world. Anit says, the questions are a little broad. Having said that, data is important to my engineering students. They struggle with data formats and general navigation of multidimensional data. Thanks, Anit. That's really interesting. And I hope that's something we can talk about today later in our session when we talk about the relevancy and how we can talk about data with our students. I'm sorry, I'm probably going to pronounce your name incorrectly. Eimer, I think, says, I use data in my research both as an input and as a result that I have to analyze. Yeah, definitely. A lot of people use our tools like Mathematica in research. And I think those of us who use Mathematica really appreciate both the data you can get from Wolfram Alpha, as well as the fact that really, a driver of our research and a driving tool of like the scientific method and the research that we do is the data that you collect. And it's important not just to collect good data, but also to do really good analytics around that data, understand that data. Thank you, everyone. If there's anything else, anyone has any other ideas, please feel free to drop them in the chat. As a reminder, if you have any questions throughout today's discussion, please feel free to leave your questions in the chat, and I'll make sure to get addressed either as soon as we can or in the Q&A that follows. So it's my pleasure today. Let's get started to hear more about the Wolfram and Microsoft partnership. It's an honor to introduce Aish, who heads strategic partnerships here at Wolfram, and Carrie from Microsoft's program management team, who's been a driving force for the partnership. Aish, would you like to kick us off?
Thanks, Kevin. Hi, everybody. This is an exciting time for Wolfram Partnerships. We now provide computational knowledge to 3 of the 4 biggest tech companies in the world: intelligent assistants, EdTech product integrations, remote controlled cloud labs that use our tech to power their platform, classroom solutions built on the Wolfram Cloud, commercial deployments with Wolfram Engine. There's a growing list of products and companies that use Wolfram Tech. And today, like Kevin said, we'll be sharing more about our partnership with Microsoft and show you what we're doing. Our long-term goal at Wolfram is to make all systematic knowledge accessible to everyone. And in this collaboration, making our computable knowledge available right now with Excel and very soon with Word is yet another step towards making this happen. Currently, users can access Wolfram entities via data types on the data tab on an Excel workbook. Wolfram language entities represent physical entities as well as mathematical and other scientific concepts. And we have millions of entities across hundreds of different entity types, also known as data types, for this integration. Every entity has related properties or data points that can be immediately retrieved and used in computations. If you caught the keynote yesterday, you may have seen Stephen talk about this a little bit and even show a little bit of a couple of examples that he tried. So you view the several domains that are currently exposed in Excel in the data types ribbon. And this is a growing list. This is a work in progress and an expanding list. You can generate visual cards that contain information about entities straight from the Wolfram knowledge base. You can autofill thousands of data values automatically and enhance your spreadsheets with real world data. It's pretty cool. I'm pleased to welcome Carrie Moran. She's a guest speaker from Microsoft, principal program manager in Excel, and she plays a big role in supporting this integration. Carrie?
Thank you. Yeah, Microsoft is excited to partner with Wolfram because of the wealth of information they provide and the strength of our partnership. Wolfram extends our data types platform beyond where we started, which was around stocks and geography, to now over 100 new domains, including food, activities, movies, locations, and more. The Wolfram expertise in each of these areas really helps us understand the value that we could provide to our users and then deliver upon that. We know that in academia that Wolfram is a trusted brand, and that credibility lends strength to our solution. Since our launch, we have seen Excel users engage across all the domains, from tracking their food to studying the periodic table. And you'll see some of those experiences today. We were able to leverage existing office engineering work for new customer value and faster learning to build upon our platform. We added new functionality, include nesting, arrays, entity values, images and cells, grouping in cards, deferred entities, and all of that's directly related to the partnership with Wolfram. Because of this strong partnership, we've been able to work hand in hand and build out our platform. Wolfram's entity data graph, curated data, and clear relationships is a natural fit for Excel. And Aish will tell us a little bit more about that. Thank you.
Thanks, Carrie. So through a installation of Wolfram Alpha in Azure, we've made over 100 data types available right now to Excel and Word. And like I said earlier, this remains an active area of development for us, both from the content and engineering sides. We're also working on exposing Wolfram data to the search experience in Word. So there you'll be able to view Wolfram results to queries that are made in the search bar of a Word document. Another scenario that we're very excited about that's in the works will enable users to write Wolfram language functions that operate on Excel cells. So in addition to accessing data from our knowledge base, which right now you can do with Excel, this will unlock the ability to call any Wolfram language function directly from Excel. So something really powerful happening there. There's a lot of energy in this partnership, and we have a terrific team supporting us on both sides. Let me pass it back to Kevin so we can get right to showing you more.
Thank you, Aish, and thank you, Carrie. Now that we know more about our joint goals in this partnership, I think there's still an open question of why does data matter in education? And to answer that question, it's a pleasure to introduce Jason from our Wolfram content team. Prior to Wolfram, Jason was an assistant professor of physical chemistry at Stevenson University for 6 years, teaching chemistry in academic and industrial settings since 2009. It's also an honor to introduce Sharon from Microsoft's education team, who's worked closely with us on the partnership, specifically looking at the partnership from an educator's point of view.
Hello, everyone. Let's see. So let's go into a little bit more about data literacy. And
we're having a technical issue. 1 second.
yeah, it's just a moment with the presentation deck. There we go. So the Wolfram and Excel partnership provides a variety of curated data to every Excel sheet. But what exactly is data? Data is a broad term for facts, values, and other bits of information that we encounter in everyday life. So what does one do with it all? Well, that brings us to the notion of data literacy, the ability to read, write, and communicate data in context. The answer is that we do everything with it, as we will see in coming slides. Just as literacy was very important for success, in previous centuries, data literacy is critical for success in this century. I'll hand it over to Sharon to talk a little bit more.
Thanks, Jason. And would you mind controlling the slides for me as well, Kevin? That would
Sure,
be
just
very
let me know when you need to move it over.
Thanks very much. So we've got kind of 3 points to land with you on why data literacy is just so important to speak about in the classroom. The first is data literacy is a skill, and it's a skill that all students really need. How do we know what skills we'll need for the future? Data science has experienced 650% job growth over the past 10 years alone since 2012. The US Bureau of Labor Statistics predicts data science to be one of the fastest growing careers, only really behind healthcare workers and clean energy operators. There's also a big gap between people who identify as data literate and businesses who believe data literacy is relevant in their industry. In a recent study, 93% of businesses thought it was important for their employees to be data literate, versus only 24% of students leaving 12th grade who were confident in their data literacy skills. There's a transition happening given the prevalence of computers. AI and computers can now answer a lot of the questions and math problems that historically have had to be done by hand. As Dr. Joe Bowler from Stanford said, who's one of the leading voices around data science and data literacy in the classroom, we don't need people to replicate what a computer can do in the 21st century. We need those creative thinkers. Students need to be able to think creatively, problem solve, and make decisions off of data. Data literacy is a skill that will be critical to students as they advance in their studies and enter the workforce. Kevin, can you advance the slide? Here's a short clip of students at Davis School District in Utah learning to use and analyze data.
So here in my classroom, we started by watching a quick video from some astronauts who talked about how they have used data specifically to help them be successful in their careers and successful in things like making it to the moon. They used that as an example. And then we pulled up a practice Excel sheet where students were able to work with data and practice using it to answer questions, to make observations, and all those things that scientists do.
Hi, my name is Jolie and I'm in 4th grade. Today we used Excel in the classroom. The data we were analyzing is like gravity and the mass of rockets and the length of rockets. It was really easy because it was like showing like bar graphs and like saying which is the third lowest or which is the third highest or which is the first highest or which has less mass in this.
It kind of just connects all those things about why do we learn this code? Why are we learning coding in our class? What does that have to do with the future? Well, that's where our future is going. So understanding that, wow, this coding I'm doing today, I can go write video games. And so I think it just gave them that inspiration and that dream, and gave them that opportunity to dream big.
We want them to identify as a problem solver and to be able to, whether they're in kindergarten or they're in 12th grade, be able to, when problems come up in their lives, to be able to solve those and look at them. And data is a huge piece to that.
Although data literacy is connected to different disciplines and different contexts, one does not have to relearn data literacy if you switch disciplines. Data literacy, therefore, is a transferable skill in complete analogy with traditional literacy. If you decide to read mysteries rather than sci-fi, you don't have to relearn how to read. You just change context, and the skill transfers with you.
Which leads us to our second point. Data surrounds us, and we'll interact with data and have data collected about us, regardless of if we're comfortable with data ourselves. To be safe and participating digital citizens, students need to understand what data is, how to read it, and how to make decisions from it.
Data may seem scary and sound intimidating, but actually you're already a master of it, whether or not you realize it. Deciding which brand of orange juice to buy based on their price, that's a data-based decision-making. Building next year's budget based on a pile of receipts from this year is data-based decision-making with a larger data set. Explaining either decision to someone else is data literacy. We all have experience with data literacy, but with the new tools, we can hone our data literacy skills. This is akin to a diver honing their innate breathing skills in order to be a professional diver.
And when we get comfortable with data and figure out how to visualize it in new ways, we can draw insights from data and figure out insights that we wouldn't have been able to tell from just a data set, that aren't clear from just individual data points. For example, here's a data set of 10 years of earthquake data for all earthquakes more than 5.5 on the Richter scale from the United States Geological Survey. It's a big data set. It's about 20,000 rows of data, and each point has 5 data points, which is 100,000 data points. It's massive. It's hard to look at it and find insights. But when we overlay it on this globe, suddenly we see why the Ring of Fire is called the Ring of Fire. Patterns start to emerge. We see why Mexico and California are earthquake prone. And finally, we see how the different plate tectonics actually emerge as we look at the globe. We can see almost a feathered pattern between Africa and South America and how they grew apart. You can actually see how they used to connect together. This is the power of visualizing big data. It helps you see what's hard to see. It helps you make what's invisible visible. Which brings us to our final point, that data literacy really evens the playing field for all students. There are so many different types of data that students can explore. They can focus on something that's a hobby or a subject that they're interested in. And they can make data and math engaging, relatable, and fun for everyone. Everything from Netflix and personalizing your recommendation results, that's using data. Cortana or Siri or Alexa learning to hear your voice, learning about your accent, learning about the different words you use. That's them collecting data and making the product better as a result of it. And all the way down to self-driving cars, which is a little bit more futuristic. That's using tons of data points to figure out how you simulate a person driving a car and how you can use a machine to do that. Data literacy acts as an equalizer, helping students advance their coursework in school, get into great universities, and lead fulfilling careers. And here are just some examples of different areas that use data in a day-to-day example, while not being something that's top of mind in terms of a data-driven career.
Introducing and nurturing data literacy can be transformative. For example, data literacy imparted by the Ingenuity program in Baltimore, Maryland, where students do high-level research at an early age, facilitates student success when they then enrolled in Stevenson University or other universities around the country. Frequently, these students would shift into other fields rather than the one that they did their Ingenuity program project in, following their scientific passions and other experiences as they proceed through their higher education. Such switches are facilitated by the data literacy, not hindered by it. And this transition into other fields is not limited to just students.
So now you've seen a bunch of really fantastic examples about where it's clear about the value of data in education. Thank you, Sharon and Jason. Let's go to Alan, who will talk about data types in Excel and what we've done here. Alan is the director of our content development here at Wolfram. Alan, would you like to take it over?
Sure. Let me go ahead and see if I can share my screen. Right, so as Kevin mentioned, I'm the director of content development for Wolfram Alpha here. I've been responsible with some of my other colleagues on the Wolfram Alpha team and others at Wolfram Research for overseeing our part of the Excel partnership, deciding what domains we were going to expose in Excel, deciding what properties were going to be exposed, working on the overall user experience. In some cases, the partnership with Excel has been a real driver for us to expand and improve the data in some domains, filling in some holes in our knowledge, fine-tuning the way we present some of that knowledge through some of our properties that are available through the Wolfram language, through Wolfram Alpha, and also now through Excel. So I'm going to this is kind of a step back from the previous talks. I'm really going to talk about the nuts and bolts of what's available in Excel from Wolfram and some of the basics about how that works, how you can access it in Excel. As has been noted a bunch of times here, we've got more than 100 different entity types that are exposed in, sorry, my screen has just frozen, that are exposed in Excel. This is spanning pretty much every major domain that we cover. So arts and media, life sciences, political and physical geography, a lot of data from astronomy. If you're familiar, and I expect many people at the conference are familiar with the entity framework in the Wolfram language, these will all be familiar types of entities. You'll understand kind of the scope of things here. Not every entity type that exists in the Wolfram language or in Wolfram Alpha is available in Excel. Some of that is just because we've done some curation and decided there are certain entity types that probably in a first release are not things that most Excel users are going to be interested in, or that don't necessarily lend themselves to interacting with those data types within an Excel spreadsheet. But a lot of things about the physical world, about scientific concepts have been exposed here. We have also created a number of reference pages for each entity type that's available in Excel. So if you go to the main page for the integration, you can go through here and you can see a little bit more about individual entity type, samples of entities, the exact properties that are exposed in Excel, and then in each case, kind of a general overview of how you can access this data within Excel. So I'm going to jump right in and give a little bit more of a step-by-step view of that. So what is currently supported in Excel? And Aisha's mentioned there are a number of other expansions and extensions of this that are coming. What's supported in Excel is typing in the name of an entity or copying and pasting lists of entities from other sources into Excel. Once you've got those in Excel, you go to the Data tab. And as Aisha also showed, there are a number of different broad data types here. These don't correspond one-to-one with entity types in the Wolfram language. But if you hover over these, you can see that they cover a number of different individual entity types. So something like locations is These are physical geography and other kinds of entities that have a geoposition. Universities is actually universities alone. Foods is foods, movies are movies, but then people spans both people and given names. Terrain is more physical geography, so a lot of different individual entity types. But the easiest thing to do just when you've got something that you want to resolve is click on the automatic button. This is really essentially trying to parse what's in that cell, going through interpreter. Again, many of you should be familiar with interpreter. And then if there's more than one interpretation, in most cases, that's going to spawn a, sorry, move a little zoom Chrome out of the way. That's going to spawn a disambiguation experience. So again, like on Wolfram Alpha, like in the Wolfram language, here is a place where you say, this is the thing that I meant. And when you get this popped up on the side, you can actually click on it and pull out more properties and be sure that that's the entity you're interested in. And when you know it's the thing you want, you select it. And now what you've got in Excel is not just a string for the Brooklyn Bridge. You've got something that is essentially a Wolfram entity, a data type in Excel terminology. The little icon here is the thing that indicates to you that this is an entity and not just a string value. And you can click on that icon and pull up a card that's going to show you all of the available properties in Excel. And again, much like Wolfram Alpha, we've organized these into other little pods that are grouped by sort of broad categories. You've got all these different values. There are strings, there are quantities, there are numbers. In Excel, there is no support currently for actually having units associated with values. So what you're going to get out for most things, if you've got the width of a bridge, you can click on this button. It's going to pull that value out. This is not actually a quantity object with a specific unit attached to it. To know the unit, you need to consult the card, and you can see all the units are listed here on all the properties. But then what you've got here, this is also, strictly speaking, not just a number. This is actually more like a formula. This is a cell that references this entity and is pulling out the value of that property here. So then I'll show you on another tab. You can pull those down. You can operate those the same way you do with other formulas in Excel and copy the general formula into other cells and reference other entities. You can also do that directly. You could go into a blank cell. You could do equals, click on that cell, and then that's saying, okay, I'm going to start with that entity, the thing that's in A2, and then dot, and you've got all of the properties that are available here. So you could click on one of those, and then again, this is essentially a formula, hit enter, and it's pulling out that value again. Now, more often, you're probably not going to be, and most users are not just working on single entities at a time. You're going to have a whole set of things that you want to resolve. And again, there are some things to kind of be aware of that we've tried to do to make the user experience a little easier. If I just have, say, Mercury, Jupiter, and Mars here, I click on automatic. I might not know there's a space button that would give me a little bit more precise interpretation. This is going to pull up, and this is indicating there are a number of different interpretations for each of these things. And so here, I've got a planet, I've got given names, I've got a fictional character. I actually want the planet in each case. And so I can just go through and say, give me all the planets. That's great. And then I've got accessible to me all the cards, all the properties for those. We've also added some support for other kinds of contextual disambiguation. So something as simple as giving a set of cells a column head, and then I say, resolve these, click on the automatic button. And because I've got planets up there, we're trying to sort of intelligently say, you know what, these all match this particular entity type. We're just going to resolve those directly to those entities. If we get it wrong, you can go in and there's a data type option on a given entity. You can say change, and that'll bring up the disambiguation experience again. You could pick a different entity if you wanted to. We also, let me show one other kind of example of this. We try to do some other kinds of intelligent disambiguation based not just on common entity types in a column. but even on property values in some cases. So we've done some curation of what properties we think are significant to look at to try to decide if all of the entities in this column share a value for this particular property, then it's more likely that the user is looking for a particular interpretation. So, always Springfield is always a great example. Select 4 cities here, try to resolve those. It's going to go in and try to turn those into entities. Champagne's the only one that we don't have disambiguation for, so it goes directly to Champagne. But then Springfield, we have lots of different Springfields. And you can go through and try to find the one you're after. If you've got some relevant context in another column, we're also going to try to consult that. So in this case, I've got states, and these are even just strings here. These aren't even entities. But we're still going to, if we just select those cities again, try to resolve that. Now this time, we've actually said, you know what? I want the Springfield in Missouri. There's Champaign, Des Moines in Iowa. I want, yep, and we actually got all those right. Also, and this is going back to the common property case, if I have a list of cities here, and these all happen to have interpretations that are in the same US states, then we're going to go in here, click the automatic button, try to resolve them. And what I've got now is Illinois, Urbana, obviously Illinois, Chicago, Illinois. So there's a lot of different ways that we've tried to do some intelligent selection. Disambiguation is obviously a big challenge here in trying to get that right. And certainly when we're talking about people using Excel and often wanting to resolve columns of dozens, even hundreds of entities at a time, we're trying to constantly tweak those heuristics so that we're getting people more directly to the things that they're after. Now, once you've got all that data, the other thing to note here, and let me go back to, I think the planets are a good case for this. Let me just select all of these. I'm going to resolve the planets because in this case, I've got all of these and there's no overlap in some of the interpretations. Like each of these has an interpretation as a planet, but there's no other entity type that is common to all of them. So we resolve to the planets. But once I've got this, then a really great thing to do is I can go insert. I can have those selected. I can insert a table. This gets turned into a table, and then I can just start pulling out properties for all of these. Let's say nearest distance from the sun, and this is going to start auto-populating a nicely formatted table with column headings, everything else, all the property values for each entity, and we can just start pulling these out. And you've got something really great to work with. And again, here we've got things that are, these are references to another cell that has an entity. I could add another entity at the bottom and then pull these down and auto-populate those things. So that's kind of the basic functionality. There's a lot of different kinds of data that are available. When you pull up a specific entity, when you say, I want Jupiter, all of the properties that are available in Excel, with some exceptions, are immediately available. We're pulling things that have been kind of pre-cached for each entity where it makes sense to have data pre-cached so it comes back very quickly. You've got all the data accessible. Each time you pull out a property into the Excel grid, you're not making another call back to Wolfram to try to get another property value out. With some exceptions, and there are things like, especially in the astro domains, where we have, let's say, sky properties. This is not just a property. This is really another set of kind of deferred properties where these are things that are time dependent. They're things that we can't cache ahead of time. They're dependent on user location. They're dependent on time. But when you pull this up, then we do make a callback. We're getting all these values. And so you've got the latest, current, best values for things that are time dependent. And you can still pull those out into the grid same way you would any other value. There are also, obviously there are other cases. Let me see if where some of the values property values for a given entity may themselves be entities. Like for this, this is a planet, the orbit center is the sun. I can click on that, and that's actually taking me not just pulling the sun entity out into the grid, but letting me go through to the card for the sun. If you can nest down and chain through references and links between entities to get to the values you want for entities that are linked to whatever thing you're starting out with in your grid, which is very cool. And there's just a lot of different ways to work with data that we've got in Excel. I think the other people who are showing here are going to demonstrate some really interesting ways that they've been able to use this basic functionality with other kinds of dynamic interactive tools in Excel to build some great templates that are really effective in teaching different concepts, and just give you a better sense of what's possible to do in Excel with this Wolfram integration and all the data that's available to people right out of the box. Now I'll stop sharing, turn it over to Kevin again.
Thank you, Alan. It's so great to see the kind of thought process that went into all the work that we've done implementing data types within Excel. Now we're really excited to share some prepackaged scenarios. We call them templates. These are accessible online with the right subscription of Microsoft 365. We'd like to share some thoughts on how the data types integration can be leveraged within a classroom with real examples and perspective from our experts. If you'd like to follow along, I will drop some links in the chat to download the templates. You will need a Microsoft 365 personal, EDU, or family account to access the integration. And to lead this section, I'd like to introduce Elisabetta, Microsoft's program manager, who's led template development, and reintroduce Jason and Sharon from earlier this afternoon.
Thanks, Kevin. Yeah, so today we would like to give you an overview of some of the templates that we built through the Wolfram partnership and the data types that Alan just walked you through. We built 9 templates, and then we have a 10th that is together with the critical distance project that Sharon will walk us through in a bit. And the templates that we like to show you out of the 9 are the planets and comets, the movie tracker, and then Jason will show you the periodic table. So let me share my screen and we can start. Okay, I think everyone can see my screen. So the planets and comets template is an astronomy template that can be used by really anyone that's either already an expert in astronomy or is just starting up. It dives deep into planets of the solar system and then comets as well. So each template has a welcome page set up with a description of all of the sheets that make up the template. The first sheet in the planet comparison sheet is an overview of all the templates. And as you can see here, we have orbital properties, physical properties, and atmosphere. And all these properties are inserted in the grid from these data types that you see here, where we can open the card and see all of the information available. And each of this data that's pulled out here is actually the result of a formula that is called dot notation and basically is dereferencing properties from the object, which is the data type here. Going to the Planet Explorer, the Planet Explorer is a way for you to get an idea of how all of the planets actually compare to each other, and especially some planets, how much bigger than others they are. So for example, here through this drop down, you can choose any of these properties. But if we look at mass, you can see that Jupiter is on a much bigger scale than any of these planets, Mercury, Venus, Earth, or Mars. And if we pick another property, let's say gravity, the charts will update as well. And then down here, there is a scaled version of what the templates look, the planets look like compared to each other. So the sun here is very big. compared to Mercury, for example. So moving on to Planet Facts. Planet Facts is a tab where you can see dive deeper into each of the planets. So here we have the size of Mercury compared to Earth, your weight on fun facts like your weight on Mercury, how high you can jump on Mercury. And then as Carrie was mentioning earlier, through this partnership, we've actually introduced new concepts in Excel, such as images and cells. So you can insert an image and here a sky map, or in this case, the current solar system configuration, right into the grid through a formula from planets, from data types and planets in this case. And down here, up here, you can choose from this arrow any other planet, and it will change the information. Going to the Comet List tab, here is a way for you to track any of your favorite comets, whether you're trying to see if they're visible from your backyard or are just interested in learning more about them. So here we have a pre-populated list with some comets, and average orbit velocity is the property extracted here, but you can choose from any of these properties that are available. Let's say you're interested in a new comet, so we can try converting the Borley comet. So here I typed in the name and then it converted to a data type, and I know that because I got an icon here in the cell, and I can click on it and see all of the information and then the average orbit velocity populated right next to it. And the comet lookup is a tab for you to actually look at the comets that you have in your comet list. So you can choose from any of them that you have from your list, and you can you can view this information such as current solar system configuration, the sky map, orbital properties, physical properties. And for example, here you can see that this does update based on the comet that we just added. So this comet is not currently visible from Earth. So we do not have a sky map for it, but as you can see, it has the solar system configuration and everything. And one thing that I like to add is that this data is not only reliable, but it's also refreshable. So this data is time sensitive and also location sensitive. So if you happen to open this template up a couple of hours later or days, or if you're just in another location, if you click on data, refresh all, the template will update and it will grab new information so you can stay up to date and actually see all of this information based on your time zone and location. So this is kind of a sneak peek on the planets and comets, and I'll move on to the other template that I like to show you, which is the movie tracker. The movie tracker is meant to be almost a database for you to either track movies that you've watched before or movies that you like to watch in the future, or for you to itemize any of the DVDs that you have in your home. The welcome page is very similar setup to the previous template that I just showed, where there is an introduction of what this template is about. So track the movies you've watched or want to watch, get more information about your movie collection, and then learn about the cast, directors, and producers. So the movie list is really the place where you can write out all of the movies that you either want to watch, have watched, or that you have at home, for example. So here are some examples to help you understand how to fill this out. But let's try one movie, Aladdin. So I can see that it's converting. And then when I see a question mark, it's because Excel is not sure which kind of entity you mean and would like your help. So here I can see that the Wolfram database actually recognizes not just one Aladdin, but 3. So I want the 2019. So I select it here and I add it to my list. And as you can see, I can, because of how the template works, it populates information for this new movie as well. So we have characters, actors, US box office, and much more. So here, this is the list of movies. So now we can actually explore what this list has and just learn more about each of the movies. So the movie dashboard is a way to look at my favorite movies and just get recently watched based on the last ones that I've added, and just get some stats on my collection. So movie time, minutes, hours, years, the ratings, which you can add back here. So for example, I can say that I liked Aladdin, let's give it a 4. I can write a review and say, great movie, great cast. And that will store that information for me. And then here I can see that Aladdin is a recently watched because I've just added, and it does come into my favorites, but I like this one better, or Black Panther. So because I gave those 5 stars and I only gave Aladdin 4. This bar here is meant to be a search bar, so you can actually look up different things. So here we have an example adventure, but let's look at romance and see what our movie collection has. So here are the movies that are romance. But what if I'm interested in looking up a certain person? Then I love Wonder Woman, so let's see if Wonder Woman will come up. And it does, because this actress is in Wonder Woman. So this is meant to be a quick way for you to search through your movie collection. And then going into the movie cast, here's where you can really look at the cast, directors, and producers for each of the movies in your collection. Here you have an image, which is, again, one of the cool things that we've introduced, the movie poster, all of this information. And then for each of the cast, you have an image, and the cast is actually what we will call a nested entity. Because really quick looking at this, if we look at, even if we pick producers, as you can see, there's a person icon here because these are actually entities within the movie. So you can explore any of them, look at their image, and then insert them into the grid. So this is how down here we have the cast with all of the information and the role that they played, and directors and producers, and you can see this same person that we were actually just looking at here. And then this list does update similar to the comment list, as I added Aladdin, and Aladdin is now in here, and I can look at any of the information on Aladdin. Yeah, so this is a little bit of what the movie tracker can do. The last tab for both the planets and comets and the movie tracker is to help you understand what else you can do with data types and how to convert to data types. So it has a quick tutorial on how to try and convert Earth, for example, in your grid, and it shows you where to go and how to extract properties. But the template is almost a prepackaged scenario that does a lot of the heavy lifting for you, where it already converts entities and extracts properties. So it's still valuable for you to check out this tab as well if you are interested in building any scenarios on your own that the templates don't have. Thank you so much. And I'd like to hand it off to Jason, who will show you the periodic table. And I'll stop sharing my screen.
Thank you, Elizabetta. Let me share my screen. And so I'd like to share the periodic table template. As a chemist, I'm very excited about the existence of this template because chemistry and Excel have been friends for a very long time. So with that, you see the landing welcome sheet is very much laid out similar to the other two that we were already walking through. We have the periodic table as the first one, and then we can compare elemental properties between the 118 elements. We can track chemical compounds, and we can explore properties of chemical compounds in addition to just looking at the elements. And then we have the ability to test or practice your knowledge learned in the area of chemistry. And as Elizabeth has said, the last sheet has the do more with data types, as we had seen in the other two. So with that, let's click over to the periodic table. So as you can see here, it's your standard periodic table following the usual IUPAC layout with the groups and the periods labeled. And each one of the cells in the periodic table is the element, and each element is a full-blown card. So we can click and get an image of the element. And again, as we've seen in a few of the demonstrations thus far, the full property card. So we can get isotopes, chemical properties, discovery properties. All that is listed in the card right at your fingertips. But in the template here, we have some the ability to pull up different properties of each element and show them on the periodic table. So I'm going to shrink down the size of the periodic table just a little bit so we can see the whole thing. And now I'm going to get rid of what we were highlighting and go over to our dropdown. And right now I have the block of the periodic table. So we see the S block in blue and the D block in yellow here and P in black. But we can pull up and plot other properties, say electron affinity, or maybe we can go over to electronegativity. And again, you see that's live updating in my workbook on my Mac, and it's pulling the data right off of Wolfram Alpha. The other feature here on the table is that we can search to highlight different elements. So if I want to look up chlorine and see where that is on the periodic table, if I'm a beginner in chemistry, I might not know where chlorine lives on the periodic table. So being able to highlight that with a gray box. We can also put in a full name of an element. So uranium is my favorite element, and so it takes the name and highlights that on the periodic table. So your introductory students in middle school, grade school can start to see where things live. You can also do fun things with a search bar. You can search for and see any of the elements that contain in the name. And as you can see, it's quite a lot. So quite a lot of exploration that can be done, whether you're a new chemistry student or you're a hobbyist or you've been doing chemistry for a few decades, as I have. Having this information right at your fingertips and being able to see it live inside of an Excel sheet is very exciting. Now, there are 118 elements currently, and many things when you're teaching chemistry, you want to compare properties across the periodic table, compare in groups of elements, and the element tab here allows you to do that, and you can compare each of the elements. We've got all of them listed. Scroll quickly through just to show that they're all there. And what defaults is the atomic symbol. But as the instructions say, you can go over here and add columns, pulling up any of the data that we have for each of our elements. And let's say we'll pull up the electronegativity. So many things are used there. And we can pull up the half-life. And we may have to adjust the values to see everything. If the value isn't available, then it's not populated, as you can see here. And so we can, if we don't want to look at half-life, we can just Control Z, get rid of that, and then go back and add another column if we're interested in it. So let's see, we'll do the density, which we should have data on that for most of the elements, except for the super heavies where it hasn't been measured. So again, you can interactively add the data. We're pulling it right live from the database, and it's updating inside of the notebook. Going over to the compound list, now we can start taking the information that we know about the elements and combining it with the entity information from the chemical entity system. And so here we've got a pre-populated list of some molecules. And we have, again, the same setup as we had with the elements, but now we can do that side-by-side comparison with molecules. And so, so here we've got ammonia and we've got the formulas. And what's really nice, again, as a chemist, is to be able to have the typeset chemical formulas where we have subscripts and superscripts as they would normally appear in a chemical formula, in a literature article or textbook. So we could add another, let's see, we've got water, methane, let's add propane. And it thinks and goes and lives update propane, excuse me, and we get the chemical formula. And now, so we've added a new molecule here, and we can go over to compound properties. And now in our dropdown, we've got the new molecule that I added in the previous sheet, propane, and we can pull that up. And what we get is quite a lot of information. So we have the periodic table over here, just as a reference, but then we get the molar mass, we have the density, the boiling point, we get a formula here, well, a structural diagram of propane, and then we get other information for the elements that are inside of propane. Propane is a hydrocarbon, so it just says carbon and hydrogen. And again, side by side, we've got the comparisons of the different elemental properties for each of the elements comprising this molecule. We can go over and get something, get ammonia and move that. So again, the structural formula updates, and we can compare things side by side. Now, the practice tab is pretty nifty. So this is definitely geared for an education environment where you might have a homework assignment for your students to practice this at home, or maybe work together in groups in sort of a competitive little, test your knowledge activity that you're doing in the classroom, or if you're in a remote environment. And what this allows you to do is we've got questions set up. And so you just, which elements have the following symbols? So H is hydrogen, so we can type that in. And just by hitting return, it goes and checks the value against the value stored in the entity and puts a check if you've got it right, and puts something else if you've got it wrong. So nickel, well, maybe we don't quite know that that's nickel. We put, maybe it's niobium. And sure enough, when you hit return, it grades it and returns, nope, you've got that not quite right. You need to go think about it again. And so besides just looking at properties of the elements, we can also do that with properties from the molecule. So here, this is a structural formula of water. And so I previously was playing around and I had put in water and I put in the molar mass and I got those correct. Now the other molecule shown here has 4 atoms. And this one I know because it's a popular molecule in organic chemistry, it's methane. I type that in, and the molar mass, golly, I just don't know the molar mass of methane. I would have to go and put in the entity and pull up its properties card so that I could go get that. But this shows some of the things that you can do inside of an Excel workbook that could be used in the classroom to help deepen students' understanding and check their understanding with simple assessments. And then lastly, as was shown before, we have the Do More with Data tabs that allows you to explore that there are other data sets just besides elements and molecules. There are quite a bit of other data that's available to you. And so with that, I will stop my share and hand off to Sharon, who will be talking about orcas.
Thanks, Jason. That was very exciting to see how we can use periodic table and the Wolfram entities actually in the classroom. So we now have an example of a slightly different take on it. Let's talk about environmental science. As a part of our Day of Data program, which is intended to bring data literacy to students who may not have been introduced to it so far, we've explored orcas And so there are orcas living in the Salish Sea, which is just off the western coast of the United States and Canada. And there are many different orcas in that pod, and that's Kiki and her family of 23 southern resident orcas. They're the J pod. So as a part of this, we are exploring through HoloLens what the family and environment of Kiki are actually as they are swimming in the Salish Sea. Visitors explore using echolocation, seeing how noise pollution affects the orcas, finding food, and navigating and communicating, and see how actually their sight blurs with noise pollution in there while they're using echolocation. This was just launched at the Smithsonian Natural History Museum, and Wolfram entities are at the core of this as we're teaching students about endangered orcas. Students have this they're able to see the powerful impact that data has, and they learn about the different factors that can be influencing Kiki and her family as they're swimming and trying to survive. Let's watch a short video to introduce us to the Day of Data Orcas program.
Orcas are social animals, just like humans. They always stay close to their families, and while they're in their family groups, they play with each other.
Data is all around us, and when we learn to read data, understand data, and gain insights from data, we can solve many of the world's most pressing challenges.
We're using AI to translate orca sounds so we can better understand what they need and help these endangered animals.
I'm hopeful because our tools are getting more powerful every day.
Powerful tools like Microsoft Excel allow us to organize, visualize, and analyze data. We can use Excel to uncover insights and make data-driven decisions. While engaging in these activities, students use data types powered by Wolfram to learn about Kiki the orca and her family's social structure directly in an Excel workbook. First, students explore data cards to learn about Kiki's family tree. Then, they learn to use dot notation for visualizing regions where southern resident orcas were recently spotted. Next, they use a variety of data and data visualization techniques to understand factors contributing to a decline in the orca population. Finally, they come up with questions and ideas to improve health of the ecosystem.
Everyone can get involved. The biggest change happens when everyone comes together and learns how to harness powerful tools.
So join us to learn more about how you can help conserve the orcas and earn your Orca Research Badge today.
So if we throw back to the very beginning of this presentation, evening the playing field for students with data literacy is all about finding what excites students, what engages them. And this is all of the templates we've been sharing, different examples of facets that you can interest students in, bring in data, and show the relationships between data. So it's great to show videos and very specific types of glimpses into it, but let's dive into the template itself to actually look at what it feels like. Here's an example of the HoloLens experience, just a snippet of it so that you can see how the orcas are swimming around. And we're actually showing the hearts as a part of the orcas so that people feel that emotional connection to the orcas and want to be able to protect them. As a part of this, we also include a bunch of teacher resources. So this whole lesson was developed by 2 middle school teachers who partnered with us closely to build out this template and build out a set of supplemental activities so that it's really a plug and play lesson for the classroom. We host all of the activities on our educator site. And for example, the video that we just showed, videos doing overviews of the workbook so that you can teach your students how to use Excel and Wolfram as a part of this. And then all of the lessons are also free, available on any device. And as you can see, I'm currently doing this in Chrome, so working on any browser as well. All of them are also standards aligned for US standards. And we also include a bunch of supplements along the way. So data is this underlying piece that students can use to make a point, lead a discussion, share information with their family. So we start to show students how they can use the data that they're learning in their lessons and then build off of that data and builds that discussion point. There are also some fun activities like setting your Outlook signature and setting your image in as a background image in a video call. So those are kind of some fun pieces that you can include as well. And then finally, as a part of this lesson, we also went and spoke with industry experts, people who are working with orcas, and asked them how data is useful in their career and how they actually work using data, so that students can see how learning about data then translates into this career opportunity and the way that they would use data in their career. Let's dive into the template itself. So during this template, it's hosted in Excel, so students start to get more of a taste of Excel itself. And this is intended for students in upper middle school to early high school. So it's students who may or may not have seen a spreadsheet or really worked with data before. We also introduce the students to the different parts of a spreadsheet and what interactions they'll need to work with. So for example, we learn about data cards and how we can find different pieces of information and build relationships between different data sets. We then have a chance to actually learn how we're using those interactions while figuring out some fun facts about orcas. So for example, compared to a human, how big is an orca? And we can see that the orca is just giant compared to the human. I saw in the chat that there was a question around building custom data types and actually pulling in your own data. Now you can't do that with Wolfram entities today, but you can pull in other data using Power Query into Excel. And this is an example of that, where we built out Kiki and her family of 23 southern resident orcas and built data cards around them so that you can actually build those relationships for your students out of a database in the background. As a part of this activity, since it's intended to be either for the classroom or for independent learning, students have these checkpoints along the way. We saw this as a part of the chemistry template as well, but as a part of this, as students are learning about Kiki, they can get real-time information about whether they're finding the right relationships, building the right information. So for example, we can see that Kiki's mother is Princess Angeline. So if we go in and sorry about that, a technical difficulty. If we go in and we fill out Princess Angeline, we actually get a check mark along the way that tells us that it's the right answer, so that students are getting that real-time feedback. And then we can also see Wolfram entities in action here, learning about killer whales and other types of animals and learning about their taxonomy. So we can actually see all of the kingdom, phylum, class, order, family, genus, species, which is very standard for upper middle school in the United States. So students are building in these concepts that they're hearing from other classes into this data-driven exercise. Again, we have a chance to try our knowledge and make sure that we're understanding things along the way, showing our understanding. And then we do the very introduction to dot notation so that students start to get a chance to apply the skills that they've learned and be introduced to very beginning coding. So for example, as I add the dot notation into these cells, I'll get that real-time feedback and see the points plot on the map after I'm actually showing all of those. And as a part of all of this, we also include a reflection experience for the students so that they're constantly drawing connections between their life and data, asking questions about data, and investigating what they can do more with data. And then finally, a teacher lesson plan is always included in these activities so that you can figure out what you as an educator need to do to really drive home those points with students, and then how you can build in other extensions and supplemental activities. I'll now pass it back to Kevin. And Kevin, you're currently muted.
Oh, thank you. Thanks, Sharon. Doubly so. Yeah, it's great. I was saying that it's great to see all the different ways that you can use data types in the classroom and some really great real life examples that Elizabetta and Jason was able to share with us. We do have time for some Q&A. So if you have any questions, please leave them in the chat and I'll ask our panelists to address those questions. Panelists, could I ask if you could turn your cameras on? But right before we start the Q&A, I do want to mention our exit survey. We'd love to hear your feedback. I will drop this link in the chat. If you could fill this out once you have a chance, we really appreciate that. So with that being said, let me start this Q&A. So we have a question, perhaps already addressed. What is the underlying data exchange mechanism and structure? Is it, for example, ODBC drivers? And yes, I might be dating myself with that reference to ODBC. Also, will this integration work equally well on Mac OS Office?
Two of us have demonstrated this working on a Mac so far. So yes, this is supported on Mac as well as Windows. The underlying integration, I think that's probably too much to go into. There was a lot of custom engineering required on both sides to hook up the pathway for parsing coming from Excel out to Wolfram servers and for the data going back into Excel. It's not just sort of a ready-made thing that everything plugged into Excel, but yeah, no, I mean it works equally well on Windows, on Mac, also on cloud versions of Office 365 too, right?
Yes, the web.
So
it works on the web
there's a
versions
platform
too.
independent support too.
Yes, I actually was demoing in the web. So we covered all of our different.
There you go.
Awesome, thank you. So another question is, my use case are medical researchers who typically like to use Excel for part of their work, but they always have a data pipeline that requires them to import or export data. Now I might be able to anchor their data science pipeline processing in Mathematica and still offer them a way to work through tabular data sets. I'm super curious to know how well the round-trip use of Excel Mathematica will be here in its data exchange either way.
Right. I mean, right now, and I clarified a little bit in the chat that what's supported right now is limited to the subset of Wolfram language entities and subset of associated properties of those entities within Excel. I think some of the questions in that thread on the chat were thinking that there was support for more sort of arbitrary functions and data and code coming from the Wolfram language into Excel. That's not there right now. Although, as Aish mentioned at the beginning, there are some interesting projects on the horizon, looking at direct support for running Wolfram language code in an Excel sheet and having it reference other values in the spreadsheet. Other integration of search and being able to look up data within Excel and Word and across Office. So there are a lot of other ways that it will be possible to bring Wolfram data and functionality into Office products.
Thank you, Alan. If there are any other questions, please leave them in the Passable chat. I'll make sure to get addressed. With our last few minutes here, is there anything else that any of our panelists want to cover or just say or look into the future?
No, I think go ahead, Alan.
No, I was just I think it'd be interesting to hear from any people who are, we have a lot of people here who are Wolfram technology enthusiasts, and I'm sure a lot of you also use Excel in various ways. It'd be really interesting to get feedback. I know it's a lot to digest right now, just the general education topics and also the details of how the integration works. I think it'll be really interesting as the conference goes on and after the conference to get any ideas, questions, wish list items, examples of how you use both Wolfram and Microsoft technologies, because we're on both sides looking at also, any way that we can leverage Wolfram's knowledge and computational abilities and incorporate those into Microsoft products. So it's great to hear any other ideas and use cases from people who know our technology.
Eric says, fantastic work. So that being said, I think I want to thank all of our panelists here today for joining us and talking more about data types, the work that we've been working on, and the importance, the relevancy of data education, especially in the workforce today. And I want to thank all of our attendees for all of your great questions and for sticking over to the end. I believe we'll probably see you guys, see this on YouTube. And I hope that you will enjoy the rest of your time at the Wolfram Tech Conference, and we hope to see you soon. Thank you.